Hi Year 2, welcome to your maths lesson for today. So kicking off with some fluency, then continuing with that make 10 strategy for subtraction. So hopefully you can see here, we're starting with the number 12, which is represented on our tens frame. 12 has got 1 10 and 2 1s. So you can see one whole 10 here and my 2 additional 1s. Now from that 12, we're going to subtract 4. But instead of subtracting 4 all in one go, we're going to partition that 4 up into smaller pieces and do it in 2 stages. So the first thing that we're going to do, remember, this is the make 10 strategy. So we need to think, what do I need to subtract from 12 to be able to make 10? So hopefully you can see, if I just highlight here, you can see that this is our full 10. How many counters do I need to subtract to leave me with my full 10? That's right, I need to subtract 2. 1, 2. Now that leaves me with my 10, but I didn't want to just subtract 2, I wanted to subtract 4. So how many more do I need to subtract? Well, 2, 3, 4. I needed to subtract 2 more to now make sure that I've subtracted 4 all together. So what we're doing is we are making 10 first of all. So 12 take away 2 equals 10. And then 10 subtract 2. Hopefully you know your number bonds to 10 really securely. You can say that 10 take away 2 leaves us with 8. Have a go at pausing the video and using the tens frames and this strategy that I've just modelled to have a go at subtracting these subtraction calculations here. Great, hopefully you've had a go at that now. So I will go through the answers. If you need a bit more time, keep the video paused. If you're ready, let's go ahead. So 14 take away 5. So this is a make 10 strategy. So what do I need to subtract from 14 to leave me with just my whole 10? Well, you can see here that this is my whole 10 and I need to subtract 1, 2, 3, 4. So I'm going to subtract those first because that leaves me with my whole 10. Now, I didn't want to just subtract 4, I wanted to subtract 5. So how many more? 4, 5. I need to subtract 1 more. So 14 take away 4 leaves me with 10, and 10 take away 1. Hopefully you know your number bonds to 10 is 9. Brilliant, well done. 11 take away 5. So once again, we're going to make 10. What do I need to subtract from 11 to leave me with just my whole 10? Well, hopefully you can see that the number 11 has got 1, 1. So to be just left with that 10, we need to subtract 1, 1. There we go. But remember, I didn't want to just subtract 1. I want to subtract 5 altogether. So what do I need to add on? So what else do I need to take away to make sure that I've altogether subtracted 5? So 1, 2, 3, 4, 5. That means I had to subtract 4 more. So 11 take away 1 left me with 10, and then 10 take away 4 more. Again, hopefully you're really confident with your number bonds to 10 and you can tell me that that is 6. Wonderful. And 14 take away 6. So what do I need to subtract from 14 to be left with just 10? Well, hopefully you can see that 14 has got 4 1s that need to be subtracted to leave me with my whole 10. But again, I didn't want to just subtract 4. Altogether, I want to subtract 6. So 4, 5, 6. How many more did I need to subtract? I needed to subtract 2 more. So what we're doing in our head is we're saying that 14 take away 4 equals 10, and then 10 take away 2 more is 8. And we can do that much more easily because we're confident with our number bonds to 10 as opposed to just doing 14 take away 6 in our heads and just knowing it. The more we practice this, the more we will build up to just being able to know it. Wonderful. So today we're going to move on to something called equivalence. So what we're going to do is we're going to start off recapping what we did yesterday. Now I've got a reasoning challenge for you. And the reasoning challenge is asking you to calculate or work out which one of these pictures is showing you 3/4 shaded in blue. So remember, think about what that denominator represents. So the denominator tells me that there are in the. So hopefully you said the denominator tells me that there are 4 equal parts in the whole. So which one of my shapes has got 4 equal parts? Well, this one's telling me that I've got 4 equal parts in my whole. This one is saying that I've got 3 parts here and 4 parts here, which we know is altogether 7 parts. So it can't be this one. And our numerator shows me how many parts I have. Well done. How many parts do I have? How many are shaded? 3 parts should be shaded. So yes, this does have 3 parts shaded, but it does not have 4 parts in my whole. So this one is showing me that there are 4 parts in my whole and 3 parts are shaded. So I know that picture A shows 3/4. Remember, when that denominator is 4, we say quarters. So I know that picture A shows 3/4 because, can you finish that sentence and pause the video to do it? And when you've got an answer, play the video to hear mine. Great, well done. So hopefully you've said that. I know that picture A shows 3/4 because there are 4 equal parts in the whole and 3 of them are shaded. Wonderful, well done. So a new one for you. What fraction of this shape is shaded? So can you write down somewhere what fraction of this shape is shaded? Great, hopefully you've done that now. So you should have said that there are 2 parts in my whole shape. So my whole shape has been split equally into 1, 2 parts. So that would be my denominator, which goes on the bottom. And how many of those parts are shaded? Well, 1 of them is shaded, so that is my numerator. So I say 1/2 of the shape is shaded. Now I'm just going to do something to our whole now. There you go. So I've just changed our fraction. What fraction is this now? Write it down. Great, so once again, we're going to start with the denominator. The bottom number tells me how many equal parts make up the whole. So in my whole shape, I've got 1, 2, 3, 4. There we go. And we have got how many of those shaded? 2 of them are shaded. Wonderful. So I have got some questions for you about how our shape changed. So what I'll do is I'll hopefully just be able to put them side by side for you. There you go. So this is what we started with. And then remember, I changed it here. Did the amount that has been shaded change? And did I change the amount of equal parts? So I'd like you to tell me what you noticed thinking about these question prompts. So did the amount that has been shaded change? Did the amount of equal parts in the whole change? What do you notice? Pause the video and share your answer. Great, hopefully you've got some ideas then. But what I'd like to do is just draw out this idea of equivalence. So what actually happened was the size of the red, whoopsie daisy, if I show you here, the whole is the same size. Yep, they're the same length and they're the same width. So the whole is the same size. And you can see here, if I put the 2 examples next to each other, that the same amount of the whole has been shaded in red. So the same proportion of the whole here is red, and the same proportion of the whole here is red. The only difference is that this whole has been split into 2 parts, and this whole has been split into 4 parts. And 1 of these parts is shaded, and 2 of these parts are shaded. But again, you can see that the same amount of the whole is shaded in red. So even though these are different fractions, they look different when you see them written as a fraction. 1/2, remember we wrote with 1 as the numerator and 2 and the denominator, and this one would be 2/4. So even though these fractions look different when I look at them as a written fraction, when you actually see them as a visual representation shaded in a shape, you can actually see that really they are the same amount of that whole that has been shaded. All I did was half that half again, and instead of having 1 shaded, I now had 2 of my parts shaded, and instead of having 2 parts, I now had 4 parts. So what we say, because 1/2 and 2/4 of our shape being shaded meant that the same amount of the whole was shaded, we say that these 2 fractions, 1/2 and 2/4, are equivalent. Okay, so equivalent means equal amount of the whole is shaded. Can we say that together? Equivalence means an equal amount of the whole is shaded. Well done. And the equivalent fraction that we're going to be looking at today is 2/4 is equivalent to 1/2. Okay, so 2/4 is equivalent to 1/2. Let's say that together. 2/4 is equivalent to 1/2. How many quarters are equivalent to 1/2? Well done if you said 2. 2/4 is equivalent to 1/2. Well done if you said that. So that is the key bit of learning that we are doing today. That means even when our shape might look different, 2/4 is an equivalent amount of the whole to 1/2. Okay, so let's have a look. So here I've got to shade the equivalent. Remember, that means equal. So shade the equivalent amount of the opposite shape. So here this one has been shaded for me. This fraction has got 4 parts in the whole, which is my denominator, and 2 of them are shaded. So 2/4 of this shape is shaded. How many of my parts do I need to shade to make it an equal or an equivalent amount to this shape here? Let's have a think. 2/4 is equivalent to 1/2. Well done. So that means when my shape is split only in 2, I need to shade one of those parts for it to be an equivalent amount. I'll show you here. There we go. Hopefully yours will be much neater than mine. So I've shaded one of them, and you can see that it is an equal amount of the whole shaded. Okay, so here, what fraction of my whole has been shaded? Well, there are 2 parts, so my denominator is 2. How many of these parts are shaded? Just 1. So we say that 1/2, well done, 1/2 of this whole is shaded. Now I need to shade some of this shape so that it is equivalent. It is equivalent. So remember, 1/2 is equivalent to how many quarters? Great, well done. 2/4 is equivalent to 1/2. And hopefully you can see that here. If I start to shade 1/4. There you go. Is this blue bit here that I've now shaded, is that an equal amount of the whole to this? No, you can see that much more of this is shaded, so that is not equivalent just yet. So that's only 1/4. If I add another quarter here, is that now equal? Is that now an equivalent amount of the whole? Great, yes it is. Hopefully you can see that they are now equivalent because the same amount of the whole has been shaded. And we know that 1/2 is equivalent to 2/4. Well done. So how much of this shape is shaded? Well done, it's split into 2 and one of them is shaded. So I say that 1/2 of this shape is shaded. How much of this shape is shaded? Well, it's split into 4 equal parts, so my denominator is 4. How many of them are shaded? 2, 2/4. Are they still equivalent? Are they equivalent? So you can see here that this half was shaded, and then when I shaded 2 of them, I shaded these 2 here, and you can see if I put them on top of each other, you can see that the same amount of that whole is shaded. There you go, exactly the same amount of the whole. What about this now? Are they still equivalent? Well, hopefully you should have said, yes, they are still equivalent. Because remember yesterday when we were shading in the different parts of the shape, we said that when we have 2/4, we can choose to shade any of those 2/4. So I could choose to shade those 2, or I could choose to shade those 2, or I could choose to shade those 2. And it doesn't matter because it is still 2/4. So that 2/4 is the same as that 2/4. It doesn't matter as long as only 2 of those quarters are shaded. So just because that is shaded instead of that doesn't mean that they are not equivalent. So it doesn't matter which parts are shaded as long as we have shaded the correct amount. And we know that 1/2 is equivalent to 2/4 all the time, even when it might not look it. 1/2 is always the same as 2/4. It's always equivalent to 2/4. So let's have a look at this one now. It's trying to trick us because I know that this fraction here has got 1, 2, 3, 4 equal parts. And how many are shaded? 1, 2. So this is showing me 2/4. Now, how do I shade an equal amount? I can't shade a bit of this here, like this, and then a bit of this one here, so that it kind of matches. I can't do that. So what do I need to do? How much of this shape do I need to shade to make it an equivalent, an equal sized amount to the blue bits in this shape? Well, hopefully you will have said that 2/4 is equivalent to 1/2. Well done. So when I have 2 equal parts, I must shade one of them in to be, I'll tell you what, I'll just do this. I must shade one of them in to be equivalent. There you go. So well done if you said that. Oh, got another tricky one this time. How much of this shape has been shaded? Well, it has been split into how many equal parts? Well done, 2. So that is my denominator. How many of these parts are shaded? 1. So this is 1/2 of the shape shaded. Now, how do I shade an equivalent amount of the whole here? Do I just draw a line across here and then just make my own line up and then shade all of this here? Is that what I do? No, we don't do that. We need to use our key fact that we're learning today. So remember, we want an equivalent amount. And how much is equivalent to 1/2? How many quarters is equivalent to 1/2? That's right. Well done if you said 2. There you go, 2 quarters. Did it have to be those 2 quarters that I shaded? No, I could have shaded those 2. I could have shaded those 2. I could have shaded those 2. Or those 2. It doesn't matter which 2 quarters I shade as long as it is only 2 of them. So 2 out of my 4 parts have been shaded and they are equivalent. Fantastic. So remember, you can shade any 2 quarters because 2 quarters is always equivalent to 1/2. So that's what we're really trying to focus on today. Equivalence means an equal amount of the whole is shaded. 2 quarters is always equivalent to 1/2, and you can shade any 2 quarters because 2 quarters is equivalent to 1/2. So what I'm going to do now is I'm going to show you how we can do this in as many ways as possible. So this question says, how many ways can we shade half of this shape? Now, half, I know that the fraction for a half looks like this. 2 as my denominator and 1 as my numerator. So that must mean that there are 2 parts in the whole. Do any of my wholes have only 2 parts? Now, how many parts do our wholes have? That's right, each one of my wholes has got 4 parts. So how many of my quarters do I need to shade to be equivalent to 1/2? Well done, you can shade any 2 quarters because 2 quarters is equivalent to 1/2. So even though this is saying how many different ways can we shade half of this shape, even though this is in quarters, doesn't matter because I know that 2 quarters is equivalent to 1/2. So I could say 1, 2. That is equivalent to 1/2. 2 out of my 4 quarters. Can you have a go at pausing the video and thinking of as many different ways as possible that you could shade these quarters and show me half? Great, hopefully you've got some ideas then. So I could have said that this is half of the shape. I could have said that this is half of the shape. I could have said that this is half of the shape. I could have said that this is half of the shape. I could have said that this is half of the shape. Or I could have said that this is half of the shape. So hopefully one of these combinations at least is one that you spotted. So remember, it doesn't matter which 2 quarters we shade. You can shade any 2 quarters because 2 quarters is equivalent to 1/2. So because there's only 2 shaded in each one of my wholes, still equivalent to 1/2 because I can shade any 2 quarters for it to be equivalent to 1/2. Why don't you pause the video and try a similar thing here? How many different ways can you show me half of this shape? Fantastic, hopefully you've had a go then. Let's have a think. So half, I know that half looks like this. So half, 1/2, that means the denominator is 2, but none of my wholes have 2 parts in them. They've all got 4 parts, but that doesn't matter because we know that when there are 4 parts, they are called quarters. And I need to shade 2 quarters to be equivalent to 1/2 or a half. So does it matter which 2 quarters we shade? No, you can shade any 2/4 because 2/4 is equivalent to 1/2. So you may have said that you could have shaded the middle two. You could have said that you may have shaded the end two, or maybe the left and the middle, or maybe the right and the middle, or maybe the right and the top one, or maybe the left and the top one. So hopefully you've got a couple of these combinations pointed out. Okay, got a word problem to finish off. So Tilly eats 1/2 of a pizza. Yummy, yummy pizza. Rob has 2/4 of a same sized pizza. Which one of them gets more pizza? Which one of them eats more? Just have a think about that for a minute. Pause the video to give yourself some thinking time if you need it. Great, hopefully you've got some ideas in your head. So let's have a look. This is Tilly's pizza. Let's say, for example, she eats 1/2 of it. So that would mean that she split it into 2 parts and she only ate 1 of them. There you go. So this is what Tilly ate. She ate 1/2 her pizza. But Rob, he didn't split his pizza in 1/2. He split his pizza into 1/4. So that means he split his into 4 equal parts and he ate 2 of them. 1, 2. Who ate more pizza? Well, hopefully you can see that they both ate the same amount of pizza. How is that possible? That's right. We know that Tilly and Rob ate the same amount of pizza because 1/2 and 2/4 are equivalent. So that's what we would write. I'll just write it here for you really quickly. Tilly and Rob ate the same amount of pizza because 1/2 and 2/4 are equivalent. There you go, fantastic. Okay, now it's time for you to have a go by yourself. So this circle sheet here is just like what we did at the beginning. It is time for you to shade an equivalent amount on the opposite shape. So you can see here that there are 2/4 of my whole shaded. So how many of these halves do you need to shade? So it is an equivalent amount. Well done. Same for all of these. And then as you go down the sheet, they get harder. They are trying to trick you. The semicircle sheet is asking for you to shade 1/2 of these shapes. Now it's trying to trick you again because 1/2 has 2 as a denominator. That means my whole must be split into 2 equal parts. Are any of my wholes here split into 2 equal parts? No, they are split into 4 equal parts. They are split into quarters. So how many quarters do I need to shade to make sure that I shade 1/2? That's right, double check your success criteria. 2/4 is equivalent to 1/2. So that means that on my shapes, I need to shade 2/4. And then you need to find another way to shade 1/2 of these shapes. Now the triangle is a little bit like the activity that we did just before the word problem, where we had to find as many different ways as possible to shade 1/2 of these shapes. The square is like the word problem with the pizza, but now it's asking you about a chocolate bar. So Mark gets 1/2 of a chocolate bar. Sam has 2/4 of an identical chocolate bar. That means it was the same chocolate bar. It was the same size chocolate bar, more importantly. Who gets more chocolate? Explain your answer. So just like I did here, you need to explain your answer with a sentence. And then the pentagon sheet to finish off is an odd one out activity. So you need to tell me which shape is the odd one out and why. And for an extra challenge, maybe you could see this as the hexagon sheet possibly. I would like you to think of a reason why each of these could maybe be the odd one out. Okay, so that pentagon sheet, just tell me once which one is the odd one out. Please try to think about the learning that we've done today. And then for that hexagon sheet, maybe you could think of a reason why each one of these examples could possibly be argued to be the odd one out. Well done, everyone. I know that was another long lesson, but we have a lot to cram into these 4 days on fractions. Looking forward to seeing you all when we come back. Keep up the hard work, and I'm looking forward to seeing the work that you send in. Bye, everyone.